So let's go over a few integrals involving the natural logarithm, that is a logarithm with base e. So let's say we have something like the integral of ln x divided by x. So what we would like to do is to do a u-substitution where we let u equal ln x. And you may recall that the derivative of ln x is just equal to 1 over x. So we would really like to rewrite this expression as an expression with only ln x terms multiplied by a factor of 1 over x. So we can actually rewrite ln x over x as 1 over x times ln x, because we just take out the x from the denominator and rewrite this as 1 over x, and then the dx stays the same. So the great thing about this is now we can set u equal ln x, so then that means du is equal to 1 over x dx. So if we look back at the expression, we can see 1 over x dx as part of the expression because we have the 1 over x at the front of the expression and the dx at the end. So we can replace this with du, and we set u to equal ln x. So we can rewrite this expression as the integral of u, where u is just equal to the ln x, and then the 1 over x dx is just replaced by du. So this entire integral is just the integral of u du, where u is equal to ln x. So now we can do this integration, and we can use the power rule, and we know that the integral of u is just equal to u squared over 2 plus some constant c. And then we know that u is equal to ln x because that's what we set u to equal to for the u substitution. So this is just equal to ln x all squared divided by 2, and then plus c stays the same, and then this is our final answer. Alright, so what about this one? How do we do the integral of 1 over x times ln x? Well, the first thing we need to do is see if we can actually rewrite this expression as a product of 1 over x times a function entirely in terms of ln x. Well, it turns out we can do that because the denominator is just x times an expression entirely in terms of ln x, and in this case it's just ln x itself. So anyways, we can rewrite this as 1 over x times 1 over ln x dx. So then the great thing about this is if we set u equal ln x, and then du would equal 1 over x dx as a consequence, then we have the 1 over x dx in the expression, so we can just replace that with du. And then this expression, 1 over ln x, is just entirely in terms of ln x. So we can use our u-substitution very nicely here. So we can just rewrite this as the integral of 1 over u, because u is just equal to ln x, and then the 1 over x dx is replaced by du. So this is just the integral of 1 over u du. So you may recall from one of the standard integrals that the integral of 1 over x is just ln of the absolute value of x. Of course, it doesn't matter which variable we use, so the integral of 1 over u du is just ln of the absolute value of u and plus some constant c. So now we need to substitute the ln x back in for u. So this just becomes ln of the absolute value of ln x, because we're substituting ln x for the u, and then the plus c stays the same. So this entire integral is just ln of the absolute value of ln x plus c. So we have a logarithm inside of a logarithm. So what if we have the integral of 1 over x times the square root of ln x dx? Well, what we can do is separate the 1 over x from the rest of the expression and rewrite this as the integral of 1 over x times 1 over the square root of ln x and dx. So now we have 1 over x multiplied by another expression entirely in terms of ln x. So now we can let u equal ln x, so this means du equals 1 over x dx. So now we can do the u substitution because we have the 1 over x dx in the expression, which becomes the du, and then 1 over the square root of ln x just becomes 1 over the square root of u. So this is just the integral of 1 over the square root of u du. The square root of u is just equal to u to the power of 1/2, so 1 divided by the square root of u is just equal to u to the power of negative 1/2. So we can rewrite this integral as the integral of u to the power of negative 1/2 du. We can use the power rule of integration to integrate this. So we need to increase the power by 1. So negative 1/2 becomes 1/2 because negative 1/2 plus 1 is equal to 1/2. And then we need to divide by the same 1/2. So dividing by 1/2 is the same as multiplying by 2. So this just becomes 2 times u to the power of 1/2 and plus some constant c. Well, we can actually rewrite 2u to the power of 1/2 as 2 times the square root of u, and the plus c stays the same. And now we need to substitute ln x for the u. So this is just equal to 2 times the square root of ln x plus c. So the main thing to look out for when doing these integrals with ln x terms is to see if you can separate out a single 1 over x term from the integrand and be left with just an expression in terms of ln x. When you can do that, it allows you to use the substitution u equals ln x, which results in a new integral which gets rid of the logarithmic terms.